Hello, this is Mr. Wynn, and today's lesson will be about solving logarithmic equations and inequalities. So, the reason why we need logarithms is because they're the only way to solve for exponents, so we can't do same bases like we've been doing. You're going to use logarithms in pre-cal, calculus, and beyond. Alright, a logarithmic equation contains one or more logarithms. You can use the definition of a logarithm, or you can use my trick, remember, logging both sides or exponentiating both sides to solve. So here's example 1. 2 to the x power equals 5. Now, no matter how hard I try, I cannot rewrite 5 as 2 to some exponent. I can't say 2 to the first, that's 2. 2 squared is 4. 2 cubed is 8. So I know it's between 2 and 3, but I need the exact number. So we use our logarithm trick. I'm trying to get the exponent. I'm trying to get that exponent x down. So I'm going to log both sides. Since I'm on the 2 side, I'm going to log base 2 both sides. So here's where I'm at right now. I logged base 2 both sides. Alright, remember, if you have a log base of a number, that cancels. All we have left is x, and technically it does go in front, because there's really x times 1, which is x, equals log base 2 of 5. And x is now by itself. If there's a number in front, say there's like a 5 here, then I have to divide by 5. But that's it. Now I can check, that's the exact answer. So let me do this. If I do 2 to the math, go up to log base 2 of 5, it gives me the answer 5. Now, if you want to see what decimal that is, let's see. Log base 2 of 5 is about 2.3219. So see, if I do 2 to the 2.3 power, it's slightly below. If I do 2 to the 2.4 power, it's slightly above 5. If I do 2 to the decimal they gave me, 2.321928.095. It basically gives me 5. It rounds up. It's extremely close. It's like 2 or 4.9999999. All right. So logarithms helps us find basically what x is if it's an exponent, and we can't do same bases. Because in the past, we did same bases means same exponents, but you can't do same bases for everything. All right. The property for equality is the same. It's also true for logarithmic functions. Basically, if you have two things, logs of the same base, and they're equal to each other, the number inside has to be the same. So for example, log base 5 of x equals log base 5 of 8. Well, they're both log base 5, so the inside has to be the same, meaning x equals 8. Now, I really want y'all to not say, well, they have the same logs, they have the same numbers inside. I would want y'all to tell me, well, exponentiate both sides by 5, because I'm trying to get rid of the word log. When you do that, those cancel. All you have left is x and 8. All right, so that's how we're going to solve example 2. Solve for x. Well, both sides have log 2. I'm trying to get rid of the word log, so I'm going to exponentiate both sides by 2. Remember, these cancel out. All I have left is what's left over. I have x squared minus 4 equals 3x. Now, if we see a quadratic, the quadratic term is not going to disappear. That means we can do quadratic formula. That requires standard form. So I'm going to subtract 3x from both sides. We're just going to combine it with, so I have x squared minus 3x minus 4 equals 0. Quadratic formula. A, B, C. A is 1, B is negative 3, C is negative 4. Fill in the formula, I know. Opposite b plus or minus square root b in parentheses squared minus 4 times a times c all over 2 times a. Let's see, the inside will be 9 plus 16, 25 over 2. Square root of 25 is a nice number. That turns into 3 plus or minus 5 over 2. Do the two cases. 3 plus 5 is 8. Divided by 2 is positive 4. 3 minus 5 is negative 2. Divided by 2 is negative 1. I have two answers. Now remember, you cannot take the log of a negative number, so you must plug them in to check. So I'll plug into the right one. See, it has 3x right here. If I plug in 4, that'd be log base 2, 3 times 4, which is 12. You can log a positive number. That's good. If I do the other side, it's going to get 12 as well, because 4 squared is 16 minus 4 is 12. So that's good. But when I try negative 1 on the right side, it becomes log base 2 of, well, 3 times the negative was negative 3. Remember, you cannot log a negative number, meaning this answer will fail. Our answer is just 4. X equals 4. So be careful of taking log of a negative number or 0, because you cannot do that. Alright, inequalities are solved the exact same way. If x is bigger than the number, you're good. Just keep whatever it is. However, if it's smaller than the number, there is a limit, a minimum. Remember, because you can't go to 0 or negatives. So you have to find where that 0 is, and I'll show you how to do that in a second. So first, just solve the problem like normal. Example 3, I need to get rid of the log words. I'm going to exponentiate both sides. Right, so I have x is greater than 3 to the 4th power. Now we're trying to find x, just tell me what the number is. So put in your calculator, what is 3 to the 4th power? So it's 3 times 3 times 3 times 3. 3 to the 4th power should be 81. Alright, x is bigger than 81. That's one answer, or that is the answer. But you have to set each log equal to 0, see what the minimum is. So the inside is just x has to be bigger than 0. So my two conditions are this: x is bigger than 0 and bigger than 81. Well, bigger than 81 covers both, so that's why we don't need this part. It just keeps going up, that's fine. It doesn't go down to one number too small. But when I try this next one, I'll show y'all. Same idea. Solve the inequality. I want to get rid of the log 4 on both sides, so I'm going to exponentiate. Alright. And all I have left is x plus 3 is greater than 2x plus 1. That's not quadratic, so no need to do quadratic formula. Just solve for x, put x on one side. So 3 is bigger than x plus 1. Subtract 1. So 2 is bigger than x, or we like x on the left, so I'm going to say x is smaller than 2. So x has to be smaller than 2. Now, x can't become, say, negative 10, because if I put negative 10 in this left one, negative 10 minus plus 3 is negative 7. You can't take the log of negative 7. That's why I have to find the smallest it can be. So this is only part of my answer. That's why I have to set each log equal to 0. It has to be greater than 0, really. So let's do this. I'll do red. So the left one, x plus 3 must be bigger than 0. If I solve, subtract 3 on both sides. X has to be bigger than negative 3. So that's the condition. That's for this one. I'll try this side. So 2x plus 1 has to be bigger than 0. So if I subtract 1 on both sides, 2x is bigger than negative 1. Divide by 2. X is bigger than negative 1/2. Alright, so x has to be bigger than negative 3. Alright, it has to be bigger than negative 1/2. Negative 1/2 covers both of them. And then x smaller than 2. So bigger than negative 1/2, but smaller than 2. We'll combine these together. Alright, so x is basically between negative 1/2 and 2. That's the real answer. So basically, if you're bigger than number like here, you're good, don't have to really check it. But if you're smaller than number, you gotta find what the smallest is, because you can't put negative or negative 100 or negative 1,000 inside, because you can't take the log of a negative. Alright, and that's it for that video. So here's the practice problem. Solve for x. I'd use the trick. Alright, if you can do that, you should be fine for class. Again, this is Mr. Wynn. Thanks for watching. See you later. Bye.